All right, welcome back to Math 980. This is section 3.1's video. 3.1 is on graphs and the rectangular coordinate system. So in the last sections we've dealt with a one-dimensional number line, right? We've thought of it as a number line, and that goes on forever in both directions. Starts at 0, we can just write numbers 1, 2, 3. These are the integers, they go on forever. They go on to the left forever as well. And this is one-dimensional because it's just simply one number line, right? We're going to talk about now a two-dimensional number system, and it's really just taking this number line and rotating it 90 degrees and creating another one, and then kind of just plopping it on top of the other. Right? I still have a 0, and then I have a 1, 2, 3. We think of increasing as going up, and decreasing is going down. Okay. And this creates a two-dimensional system, right? If we kind of draw, it's not going to look great with these markers. It'll probably look better in your book. But we can draw kind of a coordinate grid. Yeah, that looks like hell. So anyway, I'm sorry. But it looks better in the book. Take a look at the book. Right down below this video, there's a grid that it creates. So look at that. It looks way better than this. But the idea here is that we have this two-dimensional system now that we can locate points. So there's a few places that we're interested in. First, this center point right here is called the origin. It's the center, it's where we start, basically. And everything that we find, all these points that we find are relative to this origin, to this central spot here, right? And so the idea is that we would, the application here is normally if I had you all sitting in a classroom, this would be easier to show you visually, but I could pick out any student's seat by telling, say, what row they were on and what column they would be on. And that would just be essentially an ordered pair. And an ordered pair is essentially two values. One denoting the x position, and the x position is that horizontal line. Right? If my x value is 3, then I'm somewhere over here, up or down. The y value is the vertical. Right? And so an ordered pair, it's ordered because it's in this order, x first, y second. It tells us where something is. So if I had, say, the ordered pair, maybe 2, 3. I could find where that is because my x value should be 2, my y value should be 3. So this point right here has an x value of 2, a y value of 3, so it's there. That's 2, 3. If I have another point, let's say -2, 1, right? I can find that. My x value is -2, my y value is +1, so I find x is -2, and then I go up until I'm at y equals 1, and this is that point, -2, 1, and so on and so on. Right? If I have the point, say, 0, -4, right, well, if x is 0, I'm still starting at the origin, but then I go down 4, so -1, 2, 3, 4, and that's right there. So this is how we locate our ordered pairs. This is what an ordered pair is, simply the x value followed by the y value, which helps us identify a specific place in this rectangular grid coordinate system. The coordinate system is cut into 4 different quadrants. When I create this grid system, we start with quadrant 1 right here. Right? And the reason that is, well, I'll do all of them and I'll show you this. Quadrant 1, then quadrant 2, quadrant 3, and quadrant 4. And the reason they're in this weird direction is because we tend to think of this line, this positive x direction, when we start talking about things like rays and vectors and things like that, as the initial resting spot, or the initial, north, if you will. Maybe north is a bad idea. But just the initial spot, that's just starting spot, right? And as these rays continue, they go in a counterclockwise direction, and that way they swing through quadrant 1 first, and then 2, and then 3, and then 4, right? So this is a quadrant system, that's the reason behind that. Mathematically, this is how we look at it. If you get into aeronautics, flight, anything like that, then typically they like to think of north or straight up as their starting point. And we won't talk about that a whole lot because that gets confusing. We'll just talk strictly mathematically, where our positive x-axis is our initial resting place. Okay, in this section it talks also about an ordered pair being a solution to a system or to an equation. And that is to say, an ordered pair, that is an x and a y value, is a solution to an equation if when the values are substituted in it creates a true statement. Okay. That's our definition for when we have a solution. Excuse me just one second here. My black marker is running out on me. And so we can try an x and a y value into an equation to see if it's a solution. So let me get rid of this, and I'll put an example of this up there. You might be asked, is the point, and sometimes we'll refer to an ordered pair as a point because it refers to a point on the two-dimensional plane. But is the point 3, 7, for example, a solution to the equation 2x minus y equals -1? And so remember, an ordered pair is always the x value comma the y value. So to see if it's a solution here, I'm going to take my x value and replace the x with it. And I'm going to take the y value and replace the y with it. If it's true, then yes, it's a solution. So 2 times, instead of x, I have 3 that I'm inputting. Minus, instead of y, I'm going to replace that with 7. And is that equal, I don't know what that hangman looking thing was. Is that equal to -1? Well, that's 6 minus 7. Is that equal to -1? Yes. -1 on the left equals negative. I don't know why I'm hangmanning it today. But this is true, and because I come down to a true statement, then yes, it is a solution. All right, let's take a look at another one. Is the point 4, -2 a solution to 3x minus 5y equals 13? And again, I'm going to replace my x with the x value, the y with the y value, so that's 3 times 4 minus 5 times -2 equals 13, right? And that's the question, does it or does it not? Well, 3 times 4 is 12. Minus 5 times negative 2 becomes plus 10. And we can see that this is not, because that's 22. That does not equal 13. This is a no. And so it's false, and therefore it's not a solution. Does that mean that there are not any solutions to this? No, there probably are. And you can probably find one. In fact, let's just try. You might also be asked this. Complete the ordered pair. I don't know what the x value is, but let's say y is negative 2. I think that's the number we had in there for the last point. But there might be an x value that makes this true, right? So what I'll do is leave my x value, because I don't know what it is, so I'm going to try to solve for it. But I do know a y value, so I'm going to plug that in. So again, I don't know x. I'm leaving it as an x. But this y is negative 2. Is there some way to figure out an x value to make this true? Well, this is then 3x plus 10 equals 13. And if I subtract 10 from both sides, I have then 3x equals 3. Divide each side by 3, and I have x equals 1. So we found one. Right, we found a solution. If x is 1, then this works. Right? That's not the only solution. Clearly, I can put any number for y in here and figure out an x, and vice versa. I can put any number in for x and figure out a y that works for it. Right? So there's an infinite number of solutions here. I just happen to find one of them. And you'll be asked to do things like this. In the homework, you'll be asked to fill in some tables, right? Find a bunch of solutions. So let's look at a problem that looks like that. Let's say fill in the missing, it'll say something like this, fill in the missing values to find solutions to, say, 2x plus 3y equals 6. And they'll give you some, either in, a lot of times it's in a table to give you an x value and a y value, or some ordered pairs with pieces missing. We'll do it in this format. We've got 0 and I don't know for y. And then we have I don't know for x, and then the 0 for y, and then an I don't know and a 4, right? It's either listed like this, or it'll be listed like 0, comma, I don't know, and I don't know, comma, 0, and blank, comma, 4, right? Kind of the same thing. We're looking for a y value that'll make a solution when x is 0. Or we're looking for an x value that'll make a solution for when y is 0, and then another x value for when y is 4. Right? That's essentially what we're doing. So we'll start one by one. Right? We'll start with this guy here. I want to solve for this y value. So I'm going to plug in 0 for x and solve for y. So 2x, but x is 0. Maybe that is not a great idea to put a circle there. We're solving for this y, so plus 3y equals 6. But 2 times 0 is just 0, so that's gone. And so this just simplifies to 3y equals 6. If I divide both sides by 2, I get y equals 3. And I have my first value. I'm going to erase that orange work because I'm going to need that space. The next thing I want to solve for is the x value for when y is 0. And in that case, 2x, I'm looking for x, so I'm going to leave it alone, plus 3 times y, which we're saying is 0 at this point, equals 6. But again, anything times 0 is 0, so it's gone. 2x equals 6, and you can see if we divide by 2, I get x equals 3. Good enough. All right, let's look at this last one. I'm going to solve for when y is equal to 4. I'm going to get rid of this red one, so if you need to pause it, go ahead now, because here it goes. Now, I'm solving for the x value when y is 4, so nothing disappears here, but I've got still 2x. Again, I'm solving for x, so I'm leaving it as an x. Plus 3y, but y is 4 for this point, equals 6. 3 times 4 is 12, so this becomes 2x plus 12 equals 6. Subtract your 12 from both sides. This gives me 2x equals negative 6. And then divide each side by 2, and you can see that x is negative 3. And I found 3 points. Right? The point 0, 3, 3, 0, and negative 3, 4. That, I think, sums up this section and all the things that they'll ask you to do. So thank you, and I'll see you for 3.2.